pump simulator, of which this is a portable model, consists of 3 different sections. The first section is the student panel or simulation section. This controls all the dials, knobs, and gauges that you would normally have on a standard fire truck panel. The top section is the hose section and the nozzle section. With this, the instructor is able to change any hose lay at any time to any length or any diameter. He is also able to change the nozzle sizes, the types of nozzles from fog to straight stream to automatic. In addition, he's able to have elevation problems, and he can also have standpipe and relay problems. The instructor can also show the student the nozzle pressure he is obtaining at the various nozzles as this program goes on. The instructor also has a control box that enables him to open and close the various nozzles, change the amount of water taken by a standpipe or relay, simulate lines bursting, change the pump size. On this particular model, can change it from 500 to 1,250 gallons per minute. It can also change the hydrant pressure, the incoming hydrant pressure, from less than 0 to 150 psi. The instructor controls the incoming hydrant pressure. The pump panel section that the student will be operating has 3 discharge gauges, a master pressure gauge, a compound gauge or incoming pressure gauge, and a tachometer. The throttle control is the same as on a vehicle. That is, counterclockwise increases the RPM, clockwise decreases the RPM. The instructor, before the class begins, will obviously turn the system on. There is an inline fuse to ensure the safety of the operator and the instructor. The first section, and most important section, is the section that is operated by the trainee. It contains all the various controls that he would see on a pump panel. These pump panels are made by the various truck manufacturers, and they represent the various pumps that are made by Hale, Waterous, Darley, and American Godiva. The pump panel contains 3 discharge gauges, a master pressure gauge, a compound or incoming pressure gauge, a tachometer, a throttle control. The throttle control actually operates opposite to normal convention. That is, counterclockwise operation of that will increase the RPM, and clockwise operation of the throttle will decrease the RPM. This is a standard from the fire industry. The system also has a prime valve, a drain valve which simulates a master drain valve, a volume transfer switch. This changes from pressure to volume, or series into pressure. A relief valve that operates from 500 psi down to 90 psi. This valve operates such that a counterclockwise operation decreases the pressure, and an increase in pressure is caused by a clockwise operation. In addition, the student operates 3 valves. The 3 valves are connected permanently on this simulator to an 1.5 inch, 2.5 inch, and 3-inch hose respectively. The 1.5 inch hose will be fit into any type of nozzle that is desired by the instructor. To operate this, you simply open up the valve to the pressure that you want. If the nozzle is open, you can control your pressure. If the nozzle is closed, you will not be able to gate the line, the same as on a fire truck. To operate the other sequences of this, the other features of this machine, this simulator, such as the elevation, you simply come out of a hose lay, in this case a 2.5 inch hose lay, into the bottom of a ladder, and this is a 60-foot ladder we're simulating. Come out of the top of the ladder and go into a nozzle selector. In this case, we have put in a 1-inch nozzle. To operate this system, you open up your discharge line and you adjust it to approximately 180 psi. Because I have set in a single lay of 1,000 feet I have a single layer of 1,000 feet, and I adjust my nozzle pressure, my discharge pressure down to about 180 psi. That gives me 50 pounds on a nozzle, 30 pounds for the 60-foot elevation, and 100 pounds of friction loss. So I set that for 180 psi. I have 180 psi on my system coming out. I go over here and I look on my number 2 nozzle, and my nozzle pressure is about 50 psi. The pressure at the bottom of the elevation is 30 pounds higher than that. That's 80 psi. This is the way you operate a friction loss and elevation problem in one operation. I can also increase or decrease that by controlling my discharge valve, but again, my nozzle pressure will go up and my elevation pressure will go up. In addition to an elevation problem, we can also hook into a standpipe or relay problem. On a standpipe problem, we plug in from a hose right into a standpipe. The instructor is then able to change the amount of water taken by a standpipe by controlling this discharge switch. This changes the amount of water being taken by the standpipe or the relay. I will now hook the pitot gauge into the standpipe setup. I will have the discharge line fully open, and you'll see as I vary the amount of water taking, the various pressures going into the standpipe will vary considerably. The relay problem operates identically. Just plug it into the relay. The pitot gauge is put on a relay position. The instructor varies the amount of water being taken by the system by changing the nozzle size, the simulated nozzle size. When the class is finished, the instructor simply turns off the power, picks up 2,000 or 3,000 feet of hose in a couple of seconds, disconnects the plug from the wall, puts the unit on its back, inserts the instructor's control box, and closes the unit. And the class is over. It takes about 2 minutes. On the pump simulator, are you picking up voice?
Yeah, I'm going to pick it up anyway.
Okay, and then
I'll use that to go by.
And also it has an RPM, and I screwed that up.
Just keep going.
Okay. Should I go back?
No, just keep going.
Okay.
We're going to do this a couple of times.
Okay. Insert the instructor's control panel. Close the unit.
Let's do it again.
Okay. Start all over.